The combination of the concept of transform faults with the hypothesis of seafloor spreading led to the construction of the theory of plate tectonics. In this theory, the lithosphere is divided into an interlocking network of blocks termed plates. Number one, ocean ridges. Accretive or constructive plate margins mark boundaries where plates are diverging. Number two, trenches, destructive plate margins mark boundaries where two plates are converging by the mechanism of the oceanic lithosphere of one of the plates being thrust under the other, eventually to become resorbed into the sub-lithospheric mantle. Transform faults. Conservative plate margins are marked by tangential motions in which adjacent plates in relative motion undergo neither destruction nor construction. Plate tectonic theory predicts that the majority of the Earth's tectonic activity takes place at the margin of plates. Plate tectonic theory earthquakes are classified according to their focal depths: 0 to 70 km shallow focus, 70 to 300 km intermediate focus, greater than 300 km deep focus. All intermediate and deep events are associated with destructive plate margins. The deepest events recorded lie at a depth of about 670 km. Relative plate motion. The present-day motion of plates can now be measured using the techniques of space geodesy. However, these techniques were only developed in the 1980s, and ideally measurements are required over a period of 10 to 20 years. The motion of plates over the Earth's surface can be described by making use of Euler's theory. The pole and its antipole are the two unique points on the surface of the Earth that do not move relative to either of the two plates. There are three methods by which the pole of relative motion for two plates can be determined. Number one, the first and most accurate is based on the fact that for true tangential motion to occur during the relative movement of two plates, the transform faults along their common boundary must follow the traces of small circles centered upon the pole of relative motion. Number two, second method is based on the variation of spreading rate with angular distance from the pole of rotation. The final and least reliable method of determining the directions of relative motion between two plates makes use of focal mechanism solutions of earthquakes on their common margins. Divergent plate boundaries can be studied using spreading rates and transform faults. The relative motion between the major plates, averaged over the past few million years, can be determined with remarkable precision. If the motion of any one plate or plate boundary across the surface of the Earth is known, then the motion of all other plates and plate boundaries can be determined because the relative motion are known. The absolute motion of plates is much more difficult to define than the relative motion between plates at plate boundaries, not least because the whole solid Earth is in a dynamic state. An alternative model for the determination of absolute motions utilizes the information provided by volcanic hotspots on the Earth's surface. The major part of the Earth's volcanic activity takes place at plate margins. The island chains are invariably younger than the ocean crest on which they stand. An example of an oceanic island chain is the Hawaiian Emperor Chain in the north central Pacific Ocean. This chain is some 6,000 kilometers long and shows a trend from active volcanoes at Hawaii in the southeast to extinct, subdivided quiets, flat-topped seamounts in the northwest. If hotspots remain fixed and provide a framework for absolute plate motions, then paleomagnetic studies should be able to provide a test of their unchanging latitude. The stability of the boundaries between plates is dependent upon their relative volcanic velocity vectors. Only six types of triple junction are present during the current phase of plate tectonics. These are triple R, for example, the junction of East Pacific Rise and a Galapagos Rift Zone. Triple T, Central Japan. TTF, junction of Peru-Chile Trench and a West Chile Rise. FFR, possibly at the junction of Owen Fracture Zone and a Colesberg Ridge. FFT, junction of San Andreas Fault and a Mendocino Fracture Zone. RTF, mouth of Gulf of California. Thank you. Please subscribe, like, and share.